Now let us study the different means that we have in a progression. For two positive numbers x and y, we define the following three important means. The first one is called as the arithmetic mean or AM, which we denote by symbol capital A, and that is given by the formula x plus y divided by 2. Now why it is so? It is because when we say that A is the arithmetic mean between x and y, so it means that if we form a sequence as x, a and y, then it should be an AP, that is the arithmetic progression. So therefore we know that the difference between the consecutive terms of an AP should be constant. So therefore a minus x should be equal to y minus a. So rearranging that, we get the expression for a as x plus y by 2, right? So let's go ahead and see the geometric mean, that is GM, which is also denoted by capital G. This is given by the formula as square root of x into y. Now here also by geometric mean we mean that the sequence formed by x, g and y is a GP. So therefore the ratio of g is to x should be same as ratio of y is to g, which gives us g square equal to xy. So therefore g turns out to be root of x into y. Right. And lastly we have the harmonic mean denoted by HM, and we write it as capital H. This is given by the formula 2 times x into y whole upon x plus y. So that means if we have the sequence x, h and y, then this should form a harmonic progression or HP. And as per the definition of harmonic progression, the reciprocals of the terms which are in HP, so these reciprocals should form the arithmetic progression. So therefore now we know that if this second sequence is an AP, then it means the middle term 1 upon h should be the arithmetic mean of 1 upon x and 1 upon y. So using the formula that we saw for arithmetic mean, we can rearrange and finally get the expression for harmonic mean h as shown here, that is 2 into x into y whole upon x plus y. Right. Now let us go ahead and see some of the important properties or relationships between these means. Okay, so the relationship between a, g and h. First one is g square is equal to ah. Now this is very straightforward to prove, because we have to simply substitute the formula of all the three and it will be evident. So let us consider the LHS. Now you know that g is nothing but root of x into y. So when you square it, you will get x into y. That's the LHS simplified. If you consider the RHS, now here a is nothing but x plus y upon 2 multiplied by h is nothing but we saw 2 into xy upon x plus y. So therefore x plus y gets cancelled and 2 also gets cancelled, leaving only x into y, so which is same as the LHS. So therefore this property is proven, g square equal to a into h. Right. Now let's go ahead and see the next property. Now here a is greater than or equal to g, which in turn is greater than or equal to h. Right. Now let us first of all prove that a is greater than g. Right. Let us try to prove this. Then we will prove the other case or the other part, which is g is greater than h. Okay. Now the equality will hold when all the three are same. That means the two numbers are also same. So that means if we know that if x is equal to y, when both the numbers are same, then obviously the arithmetic mean will be same as the geometric mean, and that will be same as the harmonic mean. So if they are not same, if x not equal to y, then the inequality will hold. So that means in that case we will have a greater than g and greater than h. So now we are going to prove the second part, that is including the inequality, and in that also we first prove the first half, that is a greater than g. Alright, so that means we have to show that, in short, a minus g is greater than 0. Right, that means we have to prove that if we substitute the formula for a, that is x plus y upon 2 minus g is nothing but root of xy. Now we have to prove that this particular expression is greater than 0, that means it is positive. Alright, so now let us simplify and see what do we get. If we cross multiply, then we will get x plus y into 2 root xy whole upon 2. Now we can see that the numerator is nothing but the square of root x minus root y. Right, we can confirm root x square is x, then root y square is y, and the middle term is 2 into root of xy with the negative sign. Alright, so that means the numerator is root of x minus root of y the whole square, and the denominator is 2. So therefore the numerator, since it's a square, it is definitely a non-negative number, and the denominator 2 is obviously a positive number. So therefore this entire quantity is definitely going to be greater than or equal to 0. Now if x is not equal to y, then definitely the equality will not apply. So therefore in that case we keep only the greater than sign. Okay, it won't be equal to 0. So therefore in this way we have proven that a minus g is greater than 0. This is what we have proven. Now it just remains to prove that g is greater than h, so that it will prove the entire inequality. Now just now we have seen the property, the first property that connects a, g and h, which is g square equal to a upon h. So that means we can rewrite a upon g is equal to g upon h, isn't it? Right, now here if you observe from what we have just proven, that is a minus g is greater than 0, it means that a is greater than g, right? And therefore if we divide both sides by g, it means that a upon g is greater than 1, assuming g is positive, because x and y are considered to be two positive numbers. Now if a upon g is greater than 1, we know that a upon g is equal to g upon h. So therefore combining these two, we can also say that g upon h also has to be bigger than 1, which in turn means that g has to be greater than h. So you see, we have proven that a is greater than g, and we have also proven that g is greater than h. So therefore in turn finally that means a greater than g greater than h as required. Let's see one more relation. So if a, g and h are the arithmetic mean, geometric mean and harmonic mean of the three numbers denoted by a, b, c, then the equation having a, b and c as its roots is as shown here, which is x cube minus 3 into a times x square plus 3g cube whole upon h times x minus g cube is equal to 0.